Okay. In this new platform, interviewing.io. Okay, just started the timer on my end as well. Is there a timer here as well? I don't see one, to be honest. Huh. Yeah. I needed some more practice with interleaved. Some more interleaved practice where like I kind of just choose a random problem and try and solve it. This platform, I'm also reading the new Beyond Cracking the Coding interview book. It's like the 2025 edition, the one they made like 10 years later, and they linked to this kind of website. And just giving it a shot. Let's see how it goes. Immediately, I'm kind of noticing a tree kind of question. So that is interesting. I basically selected a few different options like sliding windows, string manipulation, grid and matrices, two pointers, graphs, stacks, linked list, and then it kind of gave me a random question from that selection. I don't know if this is as useful as like the grind 75 from LeetCode, but let me give this a shot. Let's see. All right, let's kind of just conduct this as I would for an interview. So hello, your interview question is below. Read the code in this pad, just like you would normally. Your AI interviewer will be able to see it. Cool. Most prolific level. Given the root of a binary tree, return the most prolific level. The prolificness of all levels, the average number of children over all the nodes in that level. Sorry, what? Given the root of a binary tree, return the most prolific level. Okay. The prolificness of all levels, the average number of children's over all the nodes in that level. Return -1 if the tree is empty. Okay. They provide an example, which is very kind of them. Don't know. I have no idea. Do I need to draw this out myself too? Like, I usually do the whiteboard. I'm noticing in the book though, there's a lot of like, especially for like Google, they use Google Docs. So, do I just need to get really good at doing this? That's gonna be kind of annoying, to be honest. So, but we have this. Level 0 has prolificness of 1. Level 1 has prolificness of 2. Level 2 has prolificness of 1.5. Level 3 has prolificness of 0. The most prolific level is 1 with a prolificness of 2. What? Hold on. I'm kind of confused. How did they even calculate? Like, okay, so here there's just 1. And it says if a level is an average number of children over all the nodes in that level. So there's just 1 children here. So how is that 2? There's no second children. Like, there's no second child. The prolificness of a level is the average number of children over all the nodes in that level. Return -1 if the tree is empty. Yeah, that's fine. Level 2 has prolificness of 1.5, so there's the average number of children, okay, over all the nodes in that level. Over all the nodes in that level. I think I get it. This node over here is the only node on this level. And the average number of children just 1. There's this node right here and just 1. So like you kind of do 1 divided by 1 and you get 1. Now at this node, the average number of children, well, there's only one node and that node has an average of 2. So 2 divided by 1 is just 2. Now here's an interesting one. Here we have one node with 2 children and one node with 1 children. We do 2, 1, 3. 3 divided by 2 is 1.2, 1.5. And then at this stage, there's no children. So 0 divided by 1, 2, 3. Well, it doesn't matter because it's still 0. Cool. They also provided constraints down here, which is nice. So it can be empty, or numbers at most 10 to the power 5. The value of each node does not matter. Does it say, okay, it does say it's empty. It can be empty. We do know it's a binary tree. What else? The value of each node doesn't really matter. Yeah, that does make sense. Okay, cool. I think I kind of understand. I'm trying to consider what other kind of edge cases or things would I need to consider here. And also, this is a text file. Can I write code in this? Oh. Okay, let me, Swift 5, is there Swift 6? Hello? Okay, yeah, just Swift 5, okay, fair enough. Cool, run. Hello world. Nice. Edge cases, test cases, I can't really think of any edge case or test cases at the moment, other than like the concerns that I already mentioned, right? Like the empty. I mean, immediately, I'm just going to take this, write a function, call it most prolific level. Okay, and then in this, I don't think I need to really create a class, so I'm just going to keep this function here. And then you're given the root of a binary tree, and it can be empty. So the first thing that you want to do is like if root is equal to nil, you want to return -1. Okay, so that just deals with that base case. Where to go? And then we want to return an integer, I think. Do I need to define this tree node? Let me just write this out. Class tree node. Hold on. Why is this giving me an error? Oh, return it. Okay. Most prolific 0. Return most prolific, and gotta have that as a variable. Some good recommendations by this ID. Nice. Wasn't expecting that. So tree node. Trying to consider, like, can we just do like an initializer and have like a val for int, have it as 0 for default. We can have a left tree node, have it as nil as default, and right tree node, have that as nil as default. Right, and I think in front of the initializer we don't really need anything. I'm pretty sure. And then one thing I'm going to do right here is var value int var left int and var right int. I think sorry, tree node. There we go. Tree node. Okay. And then just spread out self.val. Just initializing the properties with the values we get from the initializer. And self.right is equal to right. Cool. Yeah, I think that should be suffice. We're at like 10, we're almost at 11 minutes, and I'm still haven't really thought about this question. Ideally, I should be thinking about the question, like brainstorming by like 5 minutes. Oh man. Okay, let's see. So at each level, we want to take a look at all the different children. Okay. What if there are, since this is a binary tree, oh, I'm not even considering like the right subtree. I was gonna say there can only be at most 2, 4, but I mean there's this whole other subtree to consider on the right side. Okay, I mean when I think about that, I think of a breadth first search kind of approach. Like one over here, kind of one over here, right? You're looking at all the different levels on all the different nodes on this level. And I don't know, that just makes the most sense to me. So I'm gonna go with that personally. In terms of time complexity, that approach of breadth first search, that would be vertices, like, or if you say n is the number of nodes in this tree, it'd be O of n. We'd have to go through all of the different nodes in this tree. Space complexity, I feel like we'll need a queue. Worst case, that queue can be O of n if it's just, yeah, I think. Worst, yeah, that's like worst case. But really, like, you don't really have that. Or actually, no, let's not go into that. I'm just gonna say O of n, worst case. Okay, so it's at 13 minutes. I'm gonna try coding this up. I really read any pseudocode or anything, so I don't know if this idea will work or not. Ideally, I should ask the interviewer if like, you know, that's a good kind of idea, and like if I can move forward, or if I should try optimizing more, or if there's a different approach, like a depth first search, or you know. And here my AI interviewer is kind of like that. So I had a question that I like before. Something about levels, and whether like when there's a right subtree, then what was my question? Can there be more than 4, or I'm blanking out on my question. Okay, let me continue this code, and then I'll ask my fellow AI interviewer for help if needed. So we have this most prolific kind of code, and then we'll what I'll do is I'll create like a queue. I don't know how to create a queue in Swift, so I'll just kind of create it as a list. Queue, not hashtag, it should just be / queue. While queue is not empty, we want to keep on doing something, and we should probably put root in here, I think. Can I just do like this? I think so. And then we want to queue remove first node, and we can set it to a var. Okay. First, maybe like we need something like that. And then after we remove the node, we want to check if node dot left and prolificness is what we'll define as the variable. It starts at 0. Most prolific. Can I just name this result? It might, like, it's basically the most prolific level is what we're going with here. Node dot left, or I think that should be okay. Guard let left. Let's go to node dot left. Else nothing. So node also needs to be unwrapped. So what I'll do is maybe I'll do something like this. Guard let node, but then I won't be able to actually change. No, I don't need to change the node, do I? Don't think so. Guard let node. Else. What should I do in the else case? Return? Continue? I don't really have anything to do, to be honest. Same thing here. What am I gonna do? What if I do something like this? Just if let node and just wrap all of this around parentheses. I can't really think of anything else to do. We're at 18 minutes. Time is short. Ideally, I should be done in 2 minutes, but let's see if that happens. Prolificness 0. If let node dot left. If let left is equal to node dot left. We want to do something with left. And that is number of children, right? Num children. Activating Swift 5 IntelliSense. What in the world? Num children plus equals 1. And then consider replacing with a Boolean check. Yeah, maybe. So something like this. If node dot right does not equal nil, we want num children plus equal 1. Then what? And we want to continue doing this. So we want to save like the length of queue. Queue.count. All right. Initial. Maybe I'll call it like initial length and call it like q.count, and then do like for I in 0 to q.count. Right, then it would keep on doing this. And num children as well, we'd want to bring it outside. Prolificness as well, you want to bring it outside of this for loop. Hold on. I actually want to reset this. Okay, total children, right? And then number of nodes we're considering as well. So num, so this is num children on level and I is not being used. Left is not being used either. Okay, we're at 22 minutes. I feel like I'm getting close though. Jeez. So num children on level, we gotta remove, kind of add to the num children on level. And then we want to like add num nodes here as well, because this will help with the prolificness kind of calculation that we want. Yeah, average number of children. So this is like num children over all the nodes in the level. So num nodes is equal to 0. And then we want num nodes after this to be equal to plus equals 1. And then after this is dealt with, we want to prolificness is equal to num children on level, right? Num children on the level 2, and then divided by the num nodes. 2 divided by 1, which makes sense. Num nodes. And then we want like a check. Result is equal to max result or prolificness. And then initial length we want here to be like that. All right. Now I want to run this through an example, and we got the example right here. All right. So our example, this is how we define a tree node. Okay, so the root we have here. Another good thing to consider would be if it would actually do the same thing for the right nodes. But let's see. So if root is equal to nil, return -1. And var result is equal to 0. And then we're doing a max of the result versus the prolificness. And then var q is equal to root. We want to do this. We have the initial length of q.count, prolificness, num children, num nodes, and we have a for loop. Then we pop off the first element from the queue, that's a root, this one right here. We what do we do next? We take the left node, and if it does exist, I mean, that means there's a children, or a child. And then same thing for right, we increment the child, then we increment the number of nodes on this level. Maybe I should call that on level as well for consistency's sake. But prolificness. Let me leave it like that for now, and then we do. Oh, I haven't added to the queue actually, so that's gonna cause a problem. So we want to also do queue.append, and we want to do node.left like that. Same thing here. Node.right. This way, it's going to come back up here. The initial length was just 1, so we're done with that now. Now we come down here, we check. Both of these would be, well, actually there'd be 1 children and 1 node, so it'd be 1 divided by 1, 1, and that would indeed increase the result to 1. And then we come back here, we check the queue is empty. No, there's 1 element, just this. So initial count 1, prolificness is back to 0, number of children 0, and this 0, so 0 to 1, just 1 iteration. We remove this node, and we check for children. And yes, there are 2 children, so we do this, 2. Num children on level 1, num children on level 2. Append both of them to the queue, add num nodes to be 1, and that's it for the for loop. We come down, we come to the next kind of line. This would be 2, 1, that would be prolificness equals 2, and that is indeed greater than result, which was 1 from before. So now result is 2. Beautiful. Then we come here, queue not empty. No, it's not. There's 2 elements here to deal with. So let's see. What initial length? Queue.count. Var prolificness is equal to 0. What else? How do I actually test this now that I think about it? You know what? Let's not worry about that. Yeah, let's not worry about that. Length of queue.count is 2 now. Just the initial variable 0 to 2, so 2 iterations. The first one is removed. Is there a left and right node? There is. So we do that. Append it, both of them to the queue. No nodes plus equals 1. Check the for loop again. There is 1 more iteration. We remove it. We check left node none, so that we skip all that. Right node this, yes there is. We append that. Num children plus equals 1. Num nodes is 2. Then this for loop is done. We come to the next line. Prolificness, so this is 3, this is 2, 3 divided by 2 is 1.5, 1.5 is not greater than 2, so result stays at 2. Okay, then we come to these 3 over here. Now these 3, so queue.empty up here, it's not, queue.count would be 3, so 0 to 3, all these are initialized. Oops. We come over here, queue.remove first, if let node.left. Nope, there isn't. Node.right. Nope, there isn't. Nodes plus 1. And so do the same thing for these 2 as well, because there's no children. And then this is going to end up being 0. This is going to be 3. That's still less than 2. So then now this is empty. Come here, return result. This should work. Now, in terms of initializing the tree, that's looking at, I guess there's no test case or anything here, so. But let's see if there's syntax errors. There is. There is. Uh, uh, oh, I did mess up somewhere. Hold on. Hold on, hold on. Where? What? Hold on. What? Okay, so this is not properly indented into there. So like that. And this is not properly indented either. So that, and that. And then this. Beautiful. Okay. Now I'll run. Some index errors, we'll see. Reset, run. Well, there's index errors, are there? Invalid sequence. Where? Bro, that's not even part of my question. Right? Bro. How's that an error? Yeah, cool. Awesome. Wow. Nice. Well, you should get like a lot more syntax errors, which is so it's nice to get this. Let me pull up the question. Is this a legal question? Prolific level? This is not a liquid question. Most prolific level. Let me check. Because then I'll just like post it on. I don't think it is. Very interesting. How do I check that this is correct? Okay, I am done. The code. Can you take a look? Let's see, interviewer, what do you got for me? I see, let me walk it through with you. Looking at your approach, you're using a level order transversal with a queue, which makes sense for processing no levels by level. Can you walk me through your logic and explain what you're thinking your algorithm is doing? Also, I noticed there might be some issues with your current implementation. What do you think the output would be if you ran this on the example tree? I thought it would be okay. You see some issues. I just ran through it and it was fine. Disconnect from there. Okay, so hold on, I'm not finished, bro. Wait, hold on. Okay. I guess the microphone's still on. So what I'm trying to do here is the logic behind it is so like you mentioned, the level order traversal. I have the breadth first search kind of going over there. I did run through the example that was given and it seemed fine to me, to be honest. Can you kind of guide me in the direction that you want me to go in? Like, should I just try like creating the test example myself and then running it? Hold on, I'm not finished, bro. Can you trace the example step by step using the given example? Start with a node. Tell me what your values would have processed. This will help. Oh, let me just close that. Just to help us see if your logic is working as expected. Okay, they give me another hint. Look at your code on line 44 to 45. I noticed you're calculating the result inside the loop for that process. What do you think happens when you calculate prolificness rather than just the first node of a level versus after processing all the nodes on the level? After processing just root, you get one here and one here. Or you get 0 here and you at least get 1, right? There is at least 1. The risk here is that I'm dividing by, I could be dividing by 0. That's the main risk. But guaranteed to not be 0. Like this is guaranteed to run. I almost, yeah, that's what I think. Because there is at least a root at this point. If there's no root, then I just return -1. Let me try and just build that example. So let me do a few things. Most prolific level. First, I would need to create like a tree, var tree node. Maybe we'll quickly say 0, nil, and then most prolific level, nil, and then we can also just print this out. So var let level return level truth. I'll just do an underscore over there. Return level or print level. That would be more appropriate or level. And let me just run this. See what happens. -1. Yeah, that makes sense. And then let's do a tree. 0. Beautiful. That is expected. So it goes through this, removes the first node, num node says plus equals 1, 0, and then, yeah, both of these are 0, yep. And now let's do a tree node 0, nil, nil. Or maybe I'll just do tree node. Yeah. Okay, reset, run, let's see. 1 like before, yeah. 1 like before. Now this left subtree should also have a tree node. Okay, now let's see. 2. Yeah, this seems to be working, bro. It seems to be working. But maybe I'm wrong. I don't know. So now tree node 0, tree node. Ideally, like this is pretty bad practice in terms of like you ideally want to like make this a bit better, but you know what? It's okay. Still should be 2, right? Yeah, still 2. Still 2. So tree node 0, tree node nil, and then in here we have tree node that, tree node this. What if I introduce like tree node here and then do like tree node? Would that introduce 1.5 as the kind of thing? No, still 2. That's alright, right? So what I did was 1, 2, and this one has 2 as well. Okay. Now at this point, so we have root, and then initial length is 1, and then node q.remove, node.left, right? We have node.left, and node.right, we have 2. 2 divided by 1. Oh. the root has to. So it is correct. Sure, this one is now 4 divided by 2. Yeah. Ran through the test. And it's working for me. I don't know, man. I think you're gaslighting me, man. What is this, AI? I'm being gaslit. So the way Swift works is that it should actually just be integers. Oh, yeah, you're right. 1.5. 3 divided by 2. I would not consider that now that I'm thinking about it. Do I want to return an integer here for this function? And hold on. What am I, like, I'm returning the most prolific level. Yeah, I'm returning the level. I'm not even returning the thing. I'm not even returning the, oh, man. Okay. So I see it silent there. That's not good practice. So first of all, I need to deal with 1.5, right, at a calculation. Second, I need to deal with this result, which is not what we want as a return type. That's incorrect. So it is useful, right? But then I want like a mapping of the levels. So come here. I have so many variables. Oh my god. Are levels. Should I create a dictionary? Just one key var. It just contains like var result to what's it called? Most prolific to a result or to level. Right, and then gotta define a data type like int, or it could be a double actually. Right, and then we can actually just create this out here. And I'm just going to name this to result. Why don't I just name this to level, bro? Till level, and then return level. And this is not what we want. We want prolificness. If so max prolificness or Bro. It's such a simple thing, but I can't. I'm overthinking it. Okay. We need like a most prolific, like most prolific or something like this, right? Most prolific. Okay. And most prolific is associated with a level. Okay. So we're creating a data structure now. Not ideal, but it is what it is. So var most prolific 0. Okay, and then we want most prolific to level. It's gonna be a oh jeez. It's gonna be a weird one, but basically returning this. That's what we're doing. Okay, and how do you divide by like do I just change what it is to a double? I think that's what I need to do. Most prolific. Yeah, there we go. Prolific to level. No exact matches and call. But it's right there, bro. Bro. What in the world, bro? Hold on, let me. What is this? Yeah, shouldn't I be expecting an integer? I want an integer. I want an integer. Please give me an integer. Once this is done, you want levels to be incremented by 1. We're really gonna do that at the end. Levels plus equals 1. Level. Okay, am I just doing something wrong? Like what's going on? Why doesn't this work? I don't know. What's wrong with this? Prolificness cannot be of type 0. 0. Fair? Happy? Zero. Okay. Okay. Of optional type int. What do you think about code now? So, however, I'm still concerned with the placement of calculation updates. You're computing the prolificness on line 36 to 50. What do you think should happen? Should you calculate the prolificness after processing each individual node or after processing all the nodes in the complete level? After all the... Oh, hold on. There we go. Exit. Oh wait, hold on. There we go. 48 to 49, you're using addition amounts. What happened to show might arise if two different levels happen to have the exact same prolificness value? Then, oh wait, hold on. Then any level would work. Am I dumb? Oh, well, what? Really? Are you sure? Because if they have the same prolific enough, if two levels have the same prolificness, which one should return? Take a look at the problem description again. Is there any guidance about tie breaking? There isn't, bro. There isn't. I guess that's a clarification I should have asked. Good catch. Oh, thank you so much. For now, let's assume on the earliest, slowest numbered levels in the case of ties. No, it does not. Rip. Okay. If it's equal to nil, then we do this. Okay. Fix that. Oh, please. Oh my god. Did I do it? So it's all that time complexity. And worst case O(n) space complexity because of the dictionary. I guess log of it. Oh, I forgot about the Q, my bad. The maximum number of nodes on a level. Don't know what that would be exactly. Not O(n). the number of levels for the number of a binary tree can have is O of n, is O log of n. To explain the time complexity, we need to go through each of the nodes in the tree to do the calculation. If n is the number of nodes, then that's why the time complexity is O of n. Okay, let's see if my thing is correct or if it's not. Oh man, I don't remember. I remember there was like a rule for this, for the number of children. Oh man, maybe I'll just like microphone this. Okay, I don't exactly remember this formula, but I remember if we had a complete binary tree, the last level was completely filled. How many would be on that last level? There was a specific formula for this. Honestly, I'm blanking out. Could you kind of give me a hint? Two to the power of the level. Yeah. Half of the nodes in the tree. Interesting. So worst case O of n. So what would you say the overall space complexity is considering both the Q and the dictionary? I mean, the dictionary won't exactly do much, like it's just O log of n. And then there's O of n, and the O of n is more dominant, right? So the O of n will remain, and that would be the space complexity. How did it get Facebook City? Oh my god, bro. Is this like solution? Now you're using BFS. Is there anything else about your solution you'd like to discuss or edge cases that you think you would consider? No, not really. I'm gonna copy this. Can I refer to this question afterwards? Oh, it provides feedback too. Cool. Okay, but I spent like a good 1 hour on this. Jeez, well, it's a long time. But a good learning experience. That's nice. I want to do more questions though. But yeah, that's okay. Oh, no feedback. But like that, man, I was probably that good. Jeez. All right. I'm gonna close it there.